We have this series LCR circuit. We need to find the quality factor if at resonance the voltage across the capacitor is n times that of the source. So in this circuit we are taking some variables as C, L and R. So let's try and find quality factor in terms of C, L and R, because we know the other things here, that is the resonance. So that condition we know in terms of L and C. Even voltage across capacitor, so we will know that term in terms of again C, L and R. So let's try and get everything in terms of C, L and R, and hopefully things will get cancelled out and we'll get quality factor in terms of only N. So let's write quality factor first. So that we know is pi by lambda. Lambda is beta t and t is 2 pi by omega. So we'll take omega up, write it as omega naught square minus beta square. So now we can see already we can get the terms of C, L and R. So let's take beta inside, and this will be half root of omega naught by beta whole square minus 1. So let's get rid of beta. We know beta is R by 2L for a series LCR circuit. So if we do that, our quality factor formula comes to be half root 4 omega naught square L square by R square. Now let's write this in other forms also. So if we replace L by 1 by C omega naught square. So if inductance is not given, so in this problem actually all three formulas are not relevant, but in later problems we will be directly using one of these three formulas based on which of C, L, R and omega naught is given. Actually R will be there in all the formulas, but among omega naught, C and L, we'll use two of them to write the quality factor. Or you can just remember this formula and you can on the spot you can come up with which variables are given, so which variables you should include. So here let's just arrive at the other. So if we replace L by 1 by C omega naught square, we get this result. So this is in terms of omega naught and C. This was in terms of omega naught and L. Now let's get rid of omega naught itself. So omega naught will be 1 by root LC. So if you do that, this is also the quality factor. Now let's come back to our problem. So VC is given as N times maximum voltage at resonance. So voltage across capacitor will be Vm into Xc by Z, and that is given as N times V maximum. So V maximum will get cancelled. Also at resonance we know Xc is equal to 1 by omega naught C and Z is equal to R. So let's get rid of Xc and Z and put the variables which we need somewhere here. So we'll do that and we get 1 by omega naught C by R is equal to N, or omega naught CR is equal to 1 by N. So in these three equations you can see this one has the term of omega naught CR. So we'll put that value here and our answer quality factor will be half of root 4N square minus 1. Alright.